All right, everybody, welcome in to Shaping the Future of Outdoor Advertising, a WGI webinar. We're going to give everyone a few seconds here to get settled and any stragglers to hop in, and then we will get started. All right, guys, we got a good group in here. Let's go.
Hey, Dan, thank you. We appreciate it. Appreciate everybody taking some time to dial in today. We're excited, Scott and I, to share our presentation, our webinar, Shaping the Future of Outdoor Advertising. Uh, let's go ahead and provide a brief introduction. I hate when I see pictures of myself there, but here we go. I can't imagine it's already been nearly 30 years that I've been in the survey, now often referred to as the geospatial profession. Very thankful to find a career that I truly have a passion for. And while, a good portion of my career was more of the traditional survey and what I often refer to as boots on the ground, the past 13 going on 14 years with WGI, I've been very fortunate to not only continue my relationship with the department, the Florida Department of Transportation, but also utilize technology, emerging technology, to be part of, instead of projects, programs. And that's what we're going to really be talking about today, is the significance of the ODA, the Outdoor Advertising Program. And so thankful for that. Scott, tell us a little bit about yourself.
Thank you, Jeremiah. Again, my name is Scott Jones. I've been in the survey industry since I was about 16. Started off in traditional surveying. And around 2005, I migrated over to the remote sensing career path. I focused mainly on aerial LiDAR, aerial imagery, and transitioned around 2016 to more of a terrestrial-based LiDAR collection and processing. What I find intriguing about this particular program is taking a traditionally manual effort and using our ingenuity, our innovation with technology, using GIS to really kind of hit a home run as far as how we can take this particular program and bring it into the 21st century. So I look forward to talking more about some of our use cases and methodology. So with that, thank you very much.
Perfect, Scott. Let's take a quick look at WGI as far as our office locations. It's been neat to watch, over the past decade and a half, what was originally a Florida-based firm. Our corporate office is down in West Palm Beach, truly evolve into a nationwide firm. We have a strong in Texas now. Excited about just a few years ago getting established in Carolina. We did quite a bit in the Midwest, and including Illinois and Chicago. I'd be remiss if I didn't touch base real quick. Our office locations, you can see we cover Florida very well, and we'll touch base on it a little bit more. But that was very, very strategic on this program, having resources, having offices strategically located throughout Florida. Let's take a quick look at the presentation overview. This will just give you a quick snapshot. I'm not going to read each one of those, but give you a big picture view of some of the items that we're covering today. We'll start off with the highway beautification legacy. This goes back to the Highway Beautification Act of 1965. Lady Bird Johnson was absolutely instrumental in establishing this program. I admire her vision and seeing the importance of recognizing, and especially, I'm sure many of us on this call today realize the importance of transportation infrastructure and how these federal roadways, they're the backbone of our great country. For me personally, just coincidentally was traveling back from Ohio a couple days ago along I-75. We were very fortunate in this country to have infrastructure that we do, that allows us, and Lady Bird Johnson saw the importance of let's keep our highways clean. Let's not clutter too much with junkyards, with too many billboards. So I just admire the vision she had back in 1965, and then how she was instrumental in establishing those federal laws, but also here in Florida, the engineers on the call obviously intimately familiar with Chapter 471. My fellow surveyors are intimately familiar with 472. Well, Chapter 479 is the Bible for outdoor advertising. And in many instances, the Florida statutes not only meet the federal requirements, but take it a step higher. And we'll certainly touch base on that throughout the presentation today. We'll move on and do our outdoor advertising program overview. I'm going to provide an intro and give a quick backstory. And we as we're putting this presentation together, we all agreed we've got to start with safety. Especially my fellow surveyors on the call, with people out on the busy roadways, safety is important. At each and every day, there's a strong focus on safety. And while we're all creatures of habit, this program, not just in Florida, but to this date in many states, would involve people physically stopping on the side of the road, getting out of a vehicle, taking pictures, collecting measurements with a tape measure or one of those rolling wheels. And it just, man, that's dangerous. And so a lot of today, Scott and I are going to be focused on how we use that technology for safety, because here at WGI, one of our core values is passion for people, and we take it very serious. We want our guys at the end of each day to be able, or at the end of a lengthy work week, to be able to go home and see their family. So we're excited to explain to you today how we use this technology to not only do it more efficiently. We'll talk about how it's quicker, but more importantly, it's safety first. So as I mentioned, there's some primitive ways, antiquated ways that were used to collect the data previous. I've got to, one thing I've got to touch base on here real quick, because we're going to, throughout this whole presentation, talk about how we implemented this technology. But if it wasn't for Ken Pye and his group there at Central Office DOT, none of this would happen. It was their willingness to embrace this technology, because there was a significant learning curve, not only for WGI, full disclosure for us, but for them too. This was a significant change. So very thankful. Ken's got a great group there of staff, and each one of those members was willing to work with us to implement this new technology. And as seen as in this screenshot, I'm giggling because we're showing 4 places past the decimal there, but we can collect this data very accurately, very precisely. And again, the majority of this data, as Scott will go into more detail, TML, terrestrial mobile LiDAR. We're driving at the posted speed limit side, collecting this detailed point cloud, but also collecting images too, much like you see in Google Street View, but our images probably better resolution, higher frequency. And so just a quick snapshot of the type of data that we're collecting there. So as far as WGI's role and expertise, we're taking this technology, combining it, and we're going to, towards the end of this presentation, talk about possibly some of the many other ways that it can be utilized. But more importantly, we don't want to lose focus on the intent of HBA, the Highway Beautification Act. And so that's WGI's role throughout this entire program. Just some quick numbers I want to share with you. Again, this is not a specific project. It's not something that we're going to do one time. This is a 5-year contract. These billboards have to be touched once a year, to make sure that there's specific spacing requirements. We're going to talk about the haggle, the height above ground level, how high these signs can be. And so we have to monitor each one of these signs and make sure that there's no shenanigans, that signs didn't get moved. We had over 60 associates our first year involved in this, and both the data acquisition and the post-processing inside the office. Touched nearly 10,000 billboards, throughout the state. That required over 13,000 of miles to be scanned. And then towards the end of the presentation, we're going to talk about new construction, new permits, and how individual signs, we also need to monitor that process too. So at this point, I want to hand it off to Scott as we discuss this transformation.
Thank you, Jeremiah. So let's start with the whole concept of using LiDAR. As Jeremiah mentioned, there was a very manual, dare I say, antiquated way to collect sign information. A lot of measurements determined from rangefinders, and the inherent inaccuracy that comes from those data sources, lend to some heavy inconsistencies when trying to compare it against LiDAR. So, the benefit of the terrestrial mobile LiDAR, as we stated before, is safety. We're able to collect millions of high unit points at a highway speed, at a fast collection rate. That allows us to get the proper information required for the program, and we're doing it, in a cost-effective manner that allows us to collect, roads at a time in a very fast, efficient manner. It keeps the team off the side of the road and allows us to have not only the correct measurements for the program, but it's a historical data set. It's not something that you measure once and you get a different answer the next time you go out. It's there, and we can, have repeatability and redundancy when needed if we need to go back and get particular measurements, look at the data set again. It allows for a long-term fidelity and archiving capabilities. And along with the point cloud, the technology absolutely needed for this program is imagery. So along with the LiDAR, we have our camera systems attached to the LiDAR unit, and we're able to co-locate some high-resolution imagery along with the LiDAR. And the great thing about our camera systems is we can, again, like the LiDAR, collect high volumes of data at a high frame rate and get those nice, clean, still images required to get the detail of the sign along with the other assets of the surrounding area. It's very helpful when trying to make planning decisions and understanding some of the key elements that we'll talk about a little bit later in the presentation. Another kind of remarkable aspect about our camera system is we're using the still imagery, but the camera itself collects a high frame rate video, and the images themselves are captured and extracted from the video. So not only are we able to get still images, there's a video component that can be geo-referenced and coupled with the collection. So let's talk a little bit about the camera system used for this program right now. Currently, we're using the Mosaic X. It's a highly advanced image system, 72 megapixels. Currently, we're collecting at a rate of 10 meters. Every 10 meters, we're taking a picture. And, from a accuracy standpoint, so just from a little bit of a accuracy nerd standpoint, for at a distance of 33 feet, we're looking at about 0.18 inches of pixel resolution. So, the farther away you get, the more the resolution degrades. But between that first 1,500 feet, you're getting inch, if not greater, resolution. Next, let's talk about our LiDAR system. So again, coupled on top of our trucks and our vehicles, we have our Mosaic X system. We have our LiDAR system. So we have 3 in total used in this program. One of our flagship sensors is the Regal VMX 2HA. This is an industry-leading survey grade, design grade system. This is the top tier system in terms of density and precision. It's mainly used for transportation, but it's doing a great job with what we're doing here in this program. So the next is we have 2 VMY2s, which is what we call more of a suitcase system. This is a very quick, portable, easy install system. This allows us to swap vehicles depending on if we need to move it from like a car to a truck to a van. This is very flexible and versatile in those sort of situations. So between these 3 systems, we're able to deploy multiple crews out in tandem and do mass collection when needed. So we talked about mass deployment, mass data collection. Well, there's a balance to that. So when we're collecting with multiple teams during our collection cycle. We averaged over the course of our first year about 100 terabytes of data. So not only do we have multiple systems, we have a large influx pipeline of data that we have to manage. So part of our strategy is to use a GIS dashboard to allow us flexibility and situational awareness. So we're able to track the crews, track how much data is being collected with each mission, and that allows us some way to balance internally the data influx that comes in through this. So additionally, when looking further down in the presentation, we'll look at how we can utilize and quantify the GIS to do specific queries based on mission, based on status, and it allows us to keep track and scale this program in such a beautiful manner.
So Scott, real quick, and just one thing that we may want to touch base on is, I know when we were originally looking at this, and we knew that our recoil scanners were going to be not overkill, but the accuracy was going to be great, but there was some discussion as far as some of the billboards, the distance that they were off the travel lane. But if I remember correctly, haven't we been pleasantly surprised the percentage, the amount of billboards that we can capture? You just want to touch base on the success we've had there.
Yeah, absolutely. Per the statute, I want to say it's 600 plus feet off of the roadway, and given the distance capability of even the VMY2, we're still able to capture the signs and from the LiDAR and the imagery. So again, we talk about the resolution of the imagery. The closer it is, the better the resolution is. We're still able to get adequate images, at a distance from the roadway. And we'll talk a little bit about some of the methodology we use to kind of facilitate instances of LiDAR shadowing. So we'll get in a little bit about how from a small percentage, we are driving. So there are instances where we'll have LiDAR shadowing based on trucks that maybe get in the way or obscure the images. So we have a great method and tracking system to account for those missing signs that we can put back into our inventory. And if we need to either recollect or we send out an individual crew to go pick up that missing sign, we're able to keep track of all of that in a very dynamic way.
Outstanding, thank you.
Yeah. So jumping into some of our Esri GIS style tracking and how we sort of leverage this internally to help facilitate not only tracking, inventory permitting, because inventory permitting along with the actual inventory collection is also a big factor of this program. So currently we use our GIS dashboarding to track not only the field collection, which what we do with that is we have live streaming through our Field Maps app that actually tracks the car or the vehicle as it drives. So we're able to not only see what they collected, we're able to, put pertinent information, mission titles, dates, crews. We're able to track who did what, when, and then we're able to cross-reference that when the data comes in the office to ensure that the data we collected matches what we have in the office. So it allows us to get some correlation between the two data sets. And through that also, we track our inventory status, as we'll talk about a little bit later, through the whole cycle. So when it's been collected, when it's been coverage checked, whether it's in the process of being extracted, and when it's finally gone through the full system and is sent to DOT and put into their portal. We track all that through GIS, and it's been a very great system to kind of manage all the different balls and juggling all the different areas about the program. Next, we'll talk back one more. Can you go back one more? Nope. Other direction. Back one more. Yeah. The last aspect I'm going to talk about with the field maps, we talk about the inventory, collecting these signs. The permit tasks are also a key element to the contract. And so with that, we use field maps and GIS infrastructure to not only collect the data for each permit, the particular information that is required, but also the pictures and the measurements that are required for permits such as field reviews and 270s, which we'll talk about a little bit later, which are more of an as-built scenario. And all that is kept within our field maps Esri infrastructure. So we talked a little bit about the Esri management analytics side. We're going to talk a little bit more about the actual extraction of the signs from an inventory standpoint. So, we collect LiDAR and imagery. Once the data is in-house, we have an extraction tool that we allow us to create that marry the point cloud and the imagery, allows us to use the RCI routes to extract good mileposts and offsets from those routes. And when the analyst is doing the physical extraction, we're able to extract the structure ID, the location, number of faces, and other pertinent information that is required. That information is then exported out in a shapefile in a CSV, and then is run through the workflow to collate the naming associated with each of the signs. And next, I want to pass on the honoring the HBA vision to Jeremiah.
Thanks, Scott. And just real quick, Dan, if you don't mind, go a couple slides back, and I want to make sure everyone understands right there. All that data, that information that Scott highlighted. The previously done was again someone physically driving up to each sign and manually entering that information, whereas now a much more efficient way we're collecting that data through one of our Regal scanners, and then inside the safety of an office there's a technician just like all of us right now sitting behind a computer screen extracting and determining all that information. So again, more efficient, but much more safer. Just I want to make sure everybody realizes that's a significant change that's happened in this approach. But yes, as Scott was saying, honoring the original Highway Beautification Act, many times as professional surveyors, professional engineers, we ask ourselves, what's the intent? What's the intent of the law? What's the intent of the original survey? Again, I got to give a shout out to Lady Bird Johnson. What was her intent? Because especially in today's world, we can get wrapped up in technology, excited about the new gadgets. We cannot lose focus of what her intent was. And we've wrapped up our first fiscal year. We're already well into our second year. So I can say with confidence that we've bridged that historic intent of the HBA with modern, tools, modern compliance. So very, very excited about that. So we look at the next slide, integration with broader planning. And we could probably spend a whole nother day talking about ways that this data could be used in other ways. But beyond the compliance, WGI's approach integrates geospatial, environmental, and engineering expertise to support infrastructure and landscape planning too. And we can certainly in today's Q&A talk about it, but I'm excited the next couple of years how we can use this data in so many other ways to benefit the department. And with that being said, let's jump over to the future of outdoor advertising compliance. Scott?
Thank you, Jeremiah. So, we felt like we sort of had an innovative solution or take by using the TML, using a software like Esri and Topodot to kind of manage the project, but also, kind of highlight and make the extraction more efficient. So we want to take it another step. So we're like thinking, well, let's talk about doing some machine learning, see if we can do some detection. So the goal of that is we have established billboard locations, but in terms of consistency and reliability, we felt it would be a good opportunity to leverage the opportunity of machine learning and start doing auto detection of billboards. So we started off by taking our imagery from our initial run through the first year of the program, and we started labeling and IDing specific billboards that had good correlating positional values. And through that, we're able to come up with an auto detection algorithm that allows us to process the imagery, run it against the model, and get locations of every sign within the route. This allows us to kind of use that as a way to validate and find correct positioning for the signs. And we decided to take it one step further because we have the auto extraction. How do we take the auto extraction and make sure that we're using the right image, right? So the thought is currently the analyst is going and manually extracting the imagery. Well, how can we tighten that up? How can we reduce the time there? So we kind of talked about taking found positions from the auto detection. Then we do a programmatic search to find all images within a certain radius, then run that through a second detection algorithm to find the actual billboards in each sign. And then that allows not only ID the specific signs automatically, but it'll also have a nice side effect for a quality of life where it will zoom in to the sign properly. So in this example, we have our raw planar image, and we want to make sure that we're centering the image correctly on the sign to reduce the amount of clicks that the user would have to zoom in to kind of get a good detail of the sign. So this not only detects the sign, but centers and zooms in and crops the image so that you have the great resolution that we talk about with our cameras, and you're able to see that in full detail through this algorithm. So in the end, you'll be getting a cropped zoomed image specific to the sign to meet all the criteria needed for the program. So I'm going to get into a little bit of a soapbox with machine learning and how that kind of quantifies to good results, right? So everybody talks a little bit about machine learning, AI, and the statistical benefits of that. So this is a evolving model. It's not something you can train once and it works perfectly. So on the screen we have some stats based on some of our programmatic approaches. So as I said before, step one is we have the initial sign position. We kick out a radius and grab all the signs, all the images close to the sign with a certain radius. And based on this, we have a certain statistic of how many signs we're able to get. Based on that, right now we're looking at a 93% success rate on getting proper signs. And then we're looking at, once the signs are collected, we're running our object detection again to ensure that we're getting the right billboard with the right picture. Through our object detection, we're able to take, right now we're getting about a 79% success rate where it's getting the right images with the billboards. And then we have about a roughly 62% rate of getting the intended sign based on our model. So there's a little bit of a growth period there. We're going to work on it, and a way that we're maximizing the potential growth of the model is we're implementing a QC step where once the initial pictures are grabbed, we have a step where the user can then go in and identify the proper picture. Given the fact that we collect a picture every 10 meters, we want to make sure that we're giving DOT the best sign possible to give the best representative picture for the message and the best quality. So this allowed us to quickly go in, pick the picture, and then once that picture is designated, we then export the labels, which can then be fed back in the model, and we'll be able to train it in a nice cycle to increase the accuracy. And I imagine over the next year, we'll be able to bump those numbers up to a high 90. So I'm looking forward to see how this does impact us. So again, we focused so much on the inventory portion of the program. I want to touch a little bit on permitting. One of the aspects of the contract is the 270 build inspection, which is specific to a sign was permitted and then built, and we have to go out and make sure that the sign was built in accordance. So in instances, we found that when we talked about safety earlier, there's some instances where the analyst will go out and to do the inspection, and there's situations like as shown, you have a channel that separates the sign from the highway. You have highways that are high traffic. Safety is a factor. The time to get from the sign to drive all the way back around could take 30 minutes sometimes. So we thought, how can we not default back to some of the legacy technology like range finders or reflectorless total stations, which you could potentially have inaccuracy based on how it's being used. And we thought, well, let's try UAS. So in instances that apply, we have found that taking a drone out, throwing it up in the air, doing about a 2-minute collection of roughly 100 images allows us to get all the content we would need to do the inspection and the measurements. And the great thing about this is that this is something that you can do at scale. So we can have technicians spread out across the state with their drones. They do their flights. They push the imagery up to the cloud. We do the processing en route as they travel back to the office. Once the processing is done, the other analysts inside the office can pull the data down, do the measurements, submit the pictures, and that makes for a very clean, scalable workflow. So we found that this is something that we are going to implement more as time goes on.
So, Scott, you summed it up perfectly, and I'll just expand on that for a moment and tell on myself. I know when we were originally entertaining the idea of using drones, the level of accuracy needed, and kind of as I mentioned earlier in regards to TML and the inventory, I was like, come on, guys, this is overkill. What are we doing out here? But I appreciate your perseverance, and after a couple pilot runs, it became quite obvious to me that it not only saves significant time, but that that previous image where how's a inspector or field crew member going to get across the canal to do those basic measurements? It would have taken an hour or two, especially considering our projects down in Miami, the high volume of traffic. And so yeah, no, I'm glad that we, like you said, in certain instances, that's the way to go. As
Yeah, and again, as I spoke about earlier, even with the lidar, the drone imagery as well, it's something that once it's collected, it's there. It's not something you would have to go back out and try to retrace and get the same measurement. You're always going to be able to know where the measurements came from. So there's a little bit of accountability there, is that we're able to pull that data up, and if there's a question, we can use it to see what's going on, see how, if we need to remeasure it again, that the data is there. There's no question that we're going to have to go out and try to measure it again and hopefully get the same answer.
Exactly. No, well said, Scott. As we wrap things up today, Scott, I know you and I are trying to be respectful of everybody's time. We're shooting for 30 minutes. We're right at 32 minutes, and we certainly want to get questions today. So start putting some thought into questions you want to ask us. Here's some of the key takeaways that we want everyone to remember. We've leveraged this technology to transform ODA compliance. Again, touched nearly 10,000 billboards, over 13,000 miles of LiDAR data was collected. I know this group is probably tired of me talking about safety, but safety. Yeah, we're excited that we were able to be more cost efficient with this methodology, but nobody's gets hurt doing it this way. And then, as we touched base earlier too, the true intent of HBA, we haven't lost focus on that, and so still staying committed to the true intent of the Highway Beautification Act established in 1965. So looking forward to any questions, and again, appreciate everybody's time today.
All right, everybody. If anyone has any questions for Jeremiah or Scott, please go ahead and drop them in the Q&A. We'll get those answered. I got one right off the bat here for you guys. I know we touched a little bit on other applications of this data collection in other service areas or industries. Can you guys be a little bit more specific on what other areas we can use data collection like this?
Great question, Dan, and you Scott. I'm going to do the handoff to you, but I mentioned earlier we could have a whole nother presentation just on that topic. And I know asset inventory is usually one of the first things to come up, and just quantifying. There's so many roadway characteristics, and I'll use guardrail as an example. A client recently reached out to us, and we were able to successfully use this data to quantify guardrail along one of the interstates. But Scott, I know you've got several great examples too of how we can utilize this data.
Yeah, sure. I still want to kind of emphasize that since this is a yearly cycle, we're taking essentially snapshots in time, right? So in the event that there's some sort of progression project that we need, time lapse data. You're going to have multi-year passes for every instance on these roads. So you're able to do, change analysis, from, if you're looking at from a pavement assessment, you're going to have pictures based in certain areas so you can watch the situation, change over time. So that allows that opens up a lot of ideas for, we talk about AI and training, looking at predictive models based on this. So if you want to step out of the 5,000-foot view, the course of this project, as it progresses, you're going to have historical data just stacked year by year by year. And then you can look at, data as a whole and see what's changing. So I think that for me, that's a very interesting topic, is to look at, change detection and progressive, predictive change over time, I should say.
No, well said, Scott. Thank you.
All right, we got one more in the Q&A. Please, guys, if you have questions, drop them in the Q&A section. Howard is curious if WGI is pursuing opportunities to provide the same service or program in any other states for any other DOTs.
But another great question. Without hesitation, yes, we have successfully implemented this type of technology approach. In Florida, we're excited. We know we can be successful in other states, and yeah, but behind the scenes, we're certainly doing that, and excited to hopefully, be able to provide this presentation in just a year or two and showcase that success in other states.
Guys, it looks like Javara wants to know who our drone pilot is for aerial marketing content.
We certainly have some options there, for WGI. Our UAV efforts, majority of the time are for actual projects, but we can certainly assist at that capacity too. All good questions. Please keep them coming, and our contact information, email address. If you think of something later on, please don't hesitate. It's the entire outdoor advertising industry. It's a significant industry, as I mentioned earlier. Coming back home from Ohio, just and I some of you may have seen I snuck in my Buc-ee's cup here. They're very aggressive on their outdoor advertising, but it's such a significant industry, and WGI has been very thankful over the past few years. It's, if you look back to our vegetation management contract, again with central office, it's already been 7-8 years that we've been part of this industry. It's been a complete just a pleasure, and enjoyed working with it, and back to that earlier question, looking forward to expanding into other states. But certainly welcome any questions. Take a quick screenshot there, get our email address. Please reach out to us.
Yeah, guys, you guys will be receiving a follow-up email with some content on there after this. It should be done by tomorrow, so check your inboxes there. And like Jeremiah said, if you have any additional questions, their emails are right there, so feel free to send them an email, and I'm sure they'll respond expeditiously. Thank everyone. Thank you very much, Jeremiah and Scott. Thanks everyone for joining, and have a great rest of your day.
Thanks, guys. See you. Bye.